All right, now we're looking at polynomial functions. So the following expressions are examples of polynomials of one variable. So we have 1 minus 5x, 3x squared minus 5x plus 1, and x cubed plus 5. Okay, so as a result, we say that the following are symbolic representations of polynomial functions of one variable. So now instead of just saying that's an expression of it, we're going to say f of x is equal to that. Maybe g of x is equal to this, and h of x is equal to this. We're just putting it into the function notation. So whether it's f, g, or h, we could have said this was c and p and q. It wouldn't matter. We're just putting it into a function notation here. Okay. So what we're supposed to do is determine whether f of x represents a polynomial function, and if possible, identify the type of polynomial function and its degree. So we have 6x cubed minus 2x plus 7. Is that a polynomial function? Yeah, that's going to be a polynomial function. And it's going to be a cubic because it's degree 3. Okay, so we have that. What about this one? Now here we have a fractional. So this is not going to be. It's not a polynomial because the exponent on the variable is negative and it's also a fraction. So it's not going to be a polynomial function. What about this one? Well, this one's not a polynomial either. So, and this is because it's down below and it's a negative. So this is not a polynomial function. So we only ended up with one that was polynomial. And here, if we look up here, a lot of spaces, these are all, positive values. They're all polynomials and they're functions. Okay. So that's kind of how you can start looking at it. It's not polynomial because it's a negative. It's not a polynomial because it's in the denominator. All right, here we have a cubic. Most of the time we write these in order of decreasing power. So minus x cubed plus 5x is typically the way we would see this, but for some reason they're showing it here. And we're supposed to evaluate this at f of negative 1. Well, f of negative 1 is going to be here, and we go down here. It looks like it's probably about a negative 4. But now what we can do is we plug it in here and figure out what it really is. So a minus 1 cubed plus 5 times minus 1. Well, that's a minus 4. This is going to be a 1. So that's going to be a negative 1 and minus 1. So it's going to be plus 1. Oh, that's a 5. How did I get a? I took 5 minus 1, I think. So now we have 1 minus 5 is a negative 4. And that's what it kind of looks like right here is a negative 4. So that's how that would be. So graphically, you just look on the graph and see what it is, and you just move up and down wherever it's at. Mathematically, this is how you would do it. Okay. And that's what it shows here is mathematically that's how we do it. And again, they kept it in this form, but really it's I think the key reason why they did that was because of the negative here, and so that's why they did that. All right, so here, what we have is we're supposed to evaluate f of x at the given value of x. So we're going to plug in negative 2 in for x. And so when we do that, we're just going to plug in negative 2 and cube it, put negative 2 and square it, multiply and add as needed. And we just keep working our way down and working our way down. And we get f of negative 2 is equal to our 27. Again, simple math as long as you remember to put your right values in. Now, when you're doing this, since it's a negative, negative to an odd power is going to be negative. Negative to an even power is going to be positive. So that's something to think about. So odds are going to be negative and evens are going to be positive. Okay. All right, let's stop there and we'll come back for some more.